Hi, welcome back everyone. So in this one we are going to start with loops. I hope first of all you're able to understand the series and you're able to follow it. If not, please let me know in the comments if there are any issues that you're facing, any errors that you're facing in your own programs. I'll be happy to help. So now let's start with one of the most fundamental concepts in any programming language, that is loops. Now, first of all, let's understand what are loops, why are they needed, and how we can use them. Right. So, first of all, loops are nothing but a piece of code that is repeated again and again. So, let's say there is some piece of code that you want to repeat, let's say 100 times. So, this is some piece of code that you want to repeat 100 times. So, one of the, I mean, not a very good way of doing it would be just writing this entire piece of code. Let's say it's a function, let's say it's some function f. A not so elegant way of doing or achieving this task would be writing this function f 100 times, right? So you want to execute it and you just simply writing it 100 times in the program itself. So what this is going to do is it's going to make a very uh, bad code which is unreadable, and it is not going to be a very elegant or efficient code. It's not going to be it's not going to be not ele- it's not going to be an elegant piece of code. So instead of doing this, what we do is we use loops. For example, let's say okay, so there's one of the classic example to depict the importance of loops is, let's say I want to get the sum of the first n integers. So I am going to input the number n, and what we want to do is the sum of the first n integers, right? Let's say if n is 5, then what I want is I want this as my answer: 1 plus 2 plus 3 plus 4 plus 5. This is what it is. For example, there is we can also consider n as 10, and in that case it will be 1 plus 2 plus 3 plus 7, 8, 9, and then 10, right? So this is how it's going to be. But the issue with this is this does not scale really well. Let's say, for example, if you were to write n equals to 100, then it's going to be a really long, sequence of additions for you to get the answer. And what if it's 1,000? What if it's 10,000? And so on. So it doesn't really help as the program input grows or the number of statements that we want to execute repeatedly grows, which is why loops are required. So we just quickly take a look at how inconvenient that really gets. For example, I'm going to say that n equals to 5, and I'm going to define a sub variable that will be 1 plus 2 plus 3 plus 4 plus 5. But what if n was 10? Then I'd have to write few more: 6 and 7 and 8 and 9 and 10, right? Let's say I'm going to make it 50, or let's say I'll try to make it 100. Now in this case, it's really going to be extremely tiring, plus it's not going to be a very readable code. You could make out what the code is doing, but then it's not going to be very convenient to write it. So you'll have to sort of write everything 13 and then 14. So I'm just going to consider this is not a valid Python code, but sort of an example that I'm giving here: 98, 99, and 100. Right. So this is going to be a huge set of numbers that are written here, and this is not a very good practice, and it's also not recommended. So we'll take a look at Python looping structures. So basically there are three kinds of loops available in Python. So first one is a for loop. the second one is a while loop, and the third one is a do while loop, right? So what a for loop does is, well, first of all, let's just write out its syntax. So I'm just going to write the syntax of the for loop. So it's going to be for if you want to iterate over. Okay, so there's this concept of iteration that we need to understand first. So we need to understand iteration, that is repeating things multiple times. So let's say so iteration is just going to be repetition. An example for that would be, let's say, our classic example of trying to find the sum of the first n integers. So let's say s equals to 1 plus 2 plus 3 plus 4 plus 5, right? And some s1 could be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So what we see is that we are doing repeated sums, but with an increasing sequence, and the sequence is well defined. That is, let's say if I'm going to say there is some number I that I'm adding in the sequence, I am very sure that the next number is I plus 1, right? So that is the pattern it is following. So it is following an incremental pattern with the step size of 1. So it's sort of following an incremental pattern with the step size of 1, right? And so that is what the iteration would mean. Iteration would mean that you're looping with a certain step size. For example, there could be another step size, let's say S2. S2 could be something like 2 plus 4 plus 6 plus 8 and so on. So the step size here is I and I plus 2. I plus 2. Let me just get this right. I and I plus 2. So that is the step size, and the step size is completely dependent on us, or however the problem requires us to define the step size, and that can also be defined using this for loop construct. Well, the simplest syntax for loop using this step sizes or these increments, the standard increments, is like this. So the syntax. So by the way, there are multiple ways of writing a for loop. We'll just look at the most standard and the most common written syntax for loop. So this is how it goes. First, you write the keyword itself for. So let me just highlight it in the red one. Okay, what is this? For. So that's our keyword for. And then you're going to write some dummy variable, which is going to be an iterator variable, which is going to store what is the current iteration number, right? So for example, here when we are starting, the dummy variable or the iteration variable was 1 and the step size was 1. So we went to 1 plus 1, 2. Then the iteration variable became 2 and the step size was 1, which is why the next iteration variable became 3 and so on. So let me just quickly elaborate about this before we move on to the syntax. For example, this is how we do it. Let's say there is some variable I and I want to iterate from I equals to 0 to 10. So this is the range that I want to iterate over. So what I'll do is I'll define I and store it with 0. Then what I'll do is I want to go from 0 to 10 with a step size of 1. So what I'll do is we'll keep on incrementing. So let's say this is some for loop definition, and we'll keep on incrementing I equals to I plus 1. Then what will happen is I goes from 0 to 1. In the next iteration, I will go from 1 to 2. Then in the next iteration, it goes from 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, and then 9 to 10. And once the upper bound is reached, so this is what we call as the upper bound of the upper bound of the loop. So once this upper bound is reached, you will break out of the loop. So that's how it's going. So let's quickly write the syntax for the standard for loop. So simply write syntax, that is for. Okay, now let me write this Python keyword into the red marker for, and the user defined variables or identifiers in y1 for I again. Now there is another Python keyword in. So what this in does is it is going to elaborate the range. So it is going to elaborate the whatever is the range, and then there is another function which is there is another Python defined function which is called as range. What it takes is it takes two parameters, the upper bound and the lower bound. So the lower bound is 0 and the upper bound is 10. And of course we have our scope, the operator for opening a scope, which is colons, and then we are going to write by giving some level of indentation, we are going to write the statements that we want to repeat for 10 times. So that's how you write some standard for loop. So let's say I'm going to execute some function, let's say FOO 10 times. So this is what it is going to do. So this for loop, what it does is, in an equivalent program, what it will do is it will simply execute this for loop as if we were to write this function 10 times. So this is 1, 2, 3, 4 and 10. Sorry, it will start with 0. So it's actually going to execute this function 11 times, because from 0 to 10 there are 11 numbers, right? So that's where it's going to execute this function 11 times. That's what it is. And if you want to execute it 10 times, exactly 10 times, you could do something like 1 to 10, or I don't know, probably 0 to 9, or whatever seems fit according to the problem. So if we want to execute this function exactly 10 times, then you would write something like for I in the range 1 to 10. I guess the range has an upper bound. So I guess this is how you would do. So okay, this range, we'll just quickly test it. So this range means mathematically, this is how it means, I believe, although I'm not very sure, but let's just test it quickly after we're done with looking at the syntax. So what this means is it includes 0 and does not include 10. In this case, what this means is it's going to the I variable is going to be 0, 1, 2, so 1 till 9, but not 10. So it's going to exclude 10, and it's going to run till 9, that is just before 10. So this is how it might be, but I'm not clearly sure of it, but we can be sure just by looking at just by writing a simple program. But I hope you get the idea. Or let's just quickly try to do that first. So let's just say I want to print numbers between 0 and 10 range, right? So I'm just going to print I, because I is defined for the entire for loop, which is why we are able to access it within the for loop scope. So I'm just going to run this program right now. Let's just see. Okay, yeah. So as I said, it starts from 0 and it goes up till whatever is the upper bound minus 1. So it is not including the upper bound. It is not including the upper bound, right? So this is what it is. It's going to go from 0 to 9. That is, it's going to execute it. It's going to execute whatever is the statement. Let's say if this is lower bound and this is upper bound, it is going to execute the statement upper bound minus 1 minus lower bound times. So this is the number of times this entire for loop is going to execute. In our case, it is upper bound is 10 and lower bound is 0, so it's going to execute 10 minus 1 minus 0, No, not. Okay, I guess no. Let me just think about this. So this is going to execute upper bound minus lower bound times, is it? So 10 minus, if our lower bound was 1, in that case, number of times this would be executing is upper bound minus lower bound. That's 10 minus 1, which is 9. And it makes sense because this is going to go from 1 to 9. Yes, that's right. So the formula for the number of iterations this loop is going to execute is simply upper bound minus lower bound, and not upper bound minus lower bound minus something else. So that it's just upper bound minus lower bound. That is the number of times it's going to execute. The minus 1 factor comes in is because the last iteration will be going to be upper bound minus 1. So that is the last iteration. For example, if upper bound is 10, the last iteration is going to be 9, as we've seen earlier. And if upper bound is, let's say, 1, the last iteration is going to be 0, which means it is not going to execute anything inside the form. Okay, fine. I guess that is how we write the standard syntax for the for loop. So in this case, let's revise this back to 0. In this case, this for loop is going to be executed for 10 times. That is from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the iterations for which it is going to execute, and hence this for loop is going to execute for 10 times exactly. That is, considering 0 and the rest of the iteration, it is 10. Right. And let's quickly revisit this example. So what this is going to do is, let's try to run it again, and this is the output that it gives. It just prints the iterator variable. You can also call it induction variable or iterator variable, whichever you prefer. First, we take this and let's see how this is executed in the Python runtime environment. I'll just paste it here. We just increase its size. Right. So what is going to happen is, so let's say there's going to be some memory location which will be given for I, and since as we've already talked about this, so this range function is going to give us a range of numbers that is from 0, 1, 2 till 9. That is upper bound minus 1, because as we've seen, it is from lower bound to upper bound minus 1. That is not including the upper bound. Well, we could also rewrite it as something like 0 to 9, which is including the it includes the 1 minus the upper bound. So in mathematical terms, right? So this is the loop iterator variable. What happens is, initially when you start with the lower bound, what it does is it is going to store that lower bound in here in the I variable. Then it is going to go inside the for loop scope. It is also going to check if, well, first of all, before going into the for loop scope, what it is going to do is it is going to check if the iterator variable is within the limits of the range that is specified. For example, we specified from 0 to 9, 0 to 9 included, or 0 to 10, 10 excluded. So this is the range that we've specified, and it is going to check if this iterator variable is indeed within the limits of the range, it is indeed within the limits of this specified range, only then you are allowed to go inside the for loop and execute whatever are the statements inside the loop. If it is not in the limits, let's say for example there is something like 11 that is sitting in the I variable, then it is going to check, okay, you've already passed the limit that is specified for the execution of this for loop. In this case, you're not going to go inside the for loop. So this is how it's going to work. And if you want to see it, we can also try to write this for loop manually. For example, what we'll do is we'll initialize it with 0 and we'll run for I guess for I. Are we allowed to write this? I'm not exactly sure. It doesn't seem like we can. For I in, I don't know. Looks like we can't write this. It's possible for us to write manual looping structures in C and C++ because we have much more control over the exact way of execution of a loop, but not so much in Python. I'll just quickly let you know how it works in C and C++ because it's much more easier to understand it there. And since Python is a convenient language that focuses on convenience, it is quite difficult for us to understand it, how this entire loop execution happens for the first time. So the way this happens in C and C++ is this is how. First you write the keyword. By the way, I'm just going to write this C and C++ method. You write for, then you open a bracket, then you write some variable, let's say the iterator variable, and there is something called as types because you have to explicitly write types in C and C++. So this is what it does. What this means is this means you are initializing an integer to a 0 and you write this semicolon. So don't worry about the syntax too much for now, but what I want you to understand is how the loop execution actually happens in some of the lower level languages. So this semicolon just means that it's the end of the statement. So what this does is this does initialization and I is less than 10. So this means that it is going to check if I is less than 10. Only if that turns out to be true, then it is going to go inside this loop and try to execute its statement. We'll finish this part, but let me just try to rewrite this again to lack of space. This is how you write in C and C++. For int, it's also possible for us to write this declaration outside int I, and then I equals to 0, I less than 10, and since we want our step size to be 1, we could write I equals to I plus 1. So what this is going to do is it is going to have the iterator variable, and let's say there is a function f here. Sorry. So this is I variable. We are initialized it to 0, and it is then going to come here and check if it is less than 10. 0 is less than 10, it passes. Then what it is going to do is, in the first iteration, it is going to come here and execute the statement. That's right. Once it executes this statement, then it is going to go back and it is not going to reinitialize this variable again. Because if you were to reinitialize this variable, what will happen is you will always initialize it to 0. It will always turn out to be less than 10, and this loop would actually never exit. So it's going to keep on executing this forever, which is also called as infinite loops, and we'll see the cases of infinite loops in Python. So once you've done initializing it, so initialization only happens once. Once that first iteration is executed, then what is going to happen is you are going to go here in the third statement of the loop and going to increment it. You will increment it to 1, I equals to I plus 1. So you substitute 0, plus 1 will become 1, and you are going to initialize it back to I, which is how you are simply going to update the counter variable of the iterator variable to 1. Then you are going to go here and check if 1 is less than 10. It is less than 10, and you are going to come back here and execute all the for loop statements. Now once you're done with that, what you're going to do is again the same thing is going to repeat. You're going to go back to this condition, this this increment statement, it is going to pick 1 because it was 1 already. You're going to add 1 to it, it's going to become 2, and the iterator variable I will be updated with the value 2. Then you're going to compare that value, the iterator variable value, with 10. So 2 is less than 10. You're going to go inside it. It's going to be executed. Once it will be executed, it will do the same thing. It goes here, it goes here. This 2 becomes 3. 2 becomes 3. The check happens that 3 is less than 10. It is true that 3 is less than 10. Then you're going to go here and execute. And similarly, once you reach to 9, then what it is going to do is, once you've executed, let's say we'll start from 8. Assume we'll continue from 8, not started, because we started from 0. Let's say I is 8. What is going to happen is, you're going to come here, you're going to increment 8, and the iterator variable is going to become 9. Once it has become 9, you're going to go here and check if 9 is less than 10. It is less than 10, and you'll execute it, this entire for loop body. Once this is executed, what you're going to do again is, you're going to go here and it is going to do increment it. It is going to become 10. Now this iterator variable I becomes 10. Once this becomes 10, it is going to do a check over here. Is I less than 10? Is 10 less than 10? It turns out to be false. So once this turns out to be false, you will exit out of this loop and keep executing the rest of the program. And that is how you break out of the loops. Right. So it's important that you break out of the loops, because if you don't, you'll be keep on executing the same piece of code forever and ever, and it will never break out. So this sort of condition is what's called as an infinite looping, and you don't want these infinite looping behaviors in a program, because they will make your program behave erratically, and frankly the program will never terminate, right? Because it won't ever stop, and so it's going to keep on executing without stopping. So essentially, there's no use of writing such a program. It's a foul sort of a program. Right. So the way Python does it does all of that increment and condition checking inside of this range function itself, and it is only going to return you this variable I, and the rest of the checks, that is, if it is less than 10 and it's less than 10, it is greater than the 0, and if you want to break or you want to execute the loop body, this is all done. This is all done manually by the automatically done by the Python interpreter or Python runtime environment when we write this for loop statement. Right. So now let's just go and try to see an example of one of the first things that we saw is to compute the sum of the first n integers. Right. For some of the first n whole numbers, actually, well, it could be integers, but let's just stick with whole numbers for now. So what I'll do is we'll take input from the user. So I'm going to typecast it to an integer, because as we all know, the input function in Python returns a string and we want an integer to work upon. Right. So I'm not going to give any prompt over here. So I get the integer. Then what I'm going to do is I'm going to write for, and this is going to be my iterator variable, for I in range 0 to n. Right. Or, well, I want it from 1 to n, right? I want to sum the numbers from 1 to n, which means the last number the I should be holding is n, which is why I should go from 1 to n plus 1. The reason being, because if I would write n over here, the last variable, the last number that I will hold will actually be n minus 1, because as we've seen just now, the range function is going to split the last number as the upper bound minus 1, which is why I'm writing n plus 1. We'll just quickly try to print I and see if this executes. So it's waiting for the input, so I'm just going to give 10 for now. So what I'm expecting is it should print everything from 1 to 10, and that's what it does. It prints everything from 1 to 10. Let's try it one more time. I'm going to give it, let's say, 14. So it's going to print everything from 1 to 14. So remember, I variable is holding all these numbers in different iterations of this loop, right? In the first iteration, I is going to be 1, in the second one it's going to be 2, the third one it's going to be 3, fourth one it's going to be 4, and the last one is going to be 14, right? Once we exceed this range of 14, then it is going to break out of this loop. And to prove that, what I'm going to do is I'm just going to write a dummy statement here out of the loop. You'll see after printing all these numbers, it is going to print the statement out of the loop. Let's do 14 again. So this is how it does it. 1 to 14 have been printed within the for loop, and out of the for loop is printed once this for loop has been exited. So once you exit the for loop, this is where you come and keep on executing the rest of the program. Right. So our objective was to compute the sum of the first 10 integers. What we want to do is compute or calculate sum of the first n integers, or let's say whole numbers or natural numbers. Natural numbers is a more accurate depiction of what we're trying to do, is because we don't want to work with the negative integers for now. I mean, you could, but let's just keep it simple. For first n natural numbers, that is our problem statement, and let's say I'm going to give n equals 10. So what I want is I want the sum of the first 10 numbers. So this is what I want. S equals to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So I want the answer to this entire calculation. And the way that we are going to do is, we know that for loop iterator variable. So this is how it's going to work. For I in range 1 to 10, I mean, when we write n equals 10, it should mean 1 to 11, because we wanted to calculate up to 10, which means it should stop at 10. The last variable should be 10 and not 9, right? So in this case, what I is going to be 0 for the 1 for the first time, I equals to 2 for the second iteration, it's going to be 3 for the third iteration, it's going to be 4 for the fourth iteration, and so on. It's going to be I equals to 10 for the last iteration. And once when it goes and increments it to 11, it will see that the upper bound is 11 and it should exclude 11, which is why it's going to break out of the loop. That's how it's going to be. And now, since I is going to hold all these variables, so this is how it's going to work. In the first iteration, I will be holding the number 1. In the second iteration, it's going to erase it, and it is going to hold the variable, the value 2. In this following iteration, it's going to be 3, and in the last iteration, that value is going to be 10. And this value for I, it is going to change for every iteration. So, and that is how we are going to capture the sum, right? So what we are going to do is, we are going to write some dummy variable sum, and then what we are going to do is sum equals to whatever is the sum value plus what is the current I value, and that it is as simple as that. For the first iteration, when I equals to 1, what is going to happen is sum is going to be 0, because we are coming from this position. So sum is going to be 0, memory location of S will be 0, and I will also be 0. What is going to happen once we execute this statement is S equals to S plus I will be 1, and then you will be storing this 1 in the variable S. So now the S variable will be updated with value 1. I was with the value 1. You are going to come back for the second iteration. I will be 2. What you are going to do next is S will still be 1 and I will be 2 in this case. So what you are going to do is you are going to store 1 plus 2, 3 into the sum. So sum will now become 3. Now once sum becomes 3, you are going to come back into the for loop, because 2 is still less than 10, less than or equals to 10, or it's less than 11. Then some variable will be 3 and I will become 3 at this point. Now what it is going to do is it's going to add this and it's going to become 6, and it's going to store 6 back into the sum. This I was supposed to be 3. We'll come back into the for loop. I will become 4, sum is 6 and I is 4. This will become 10 and you'll store it back into the sum. So sum will become 10 now, and so on and so forth. This is how it is actually going to do the computation. Right, so let's just quickly write it. What I'm going to do is write the sum variable, sum equals to 0. This time I don't want to print it, but I actually want to accumulate this sum. So it will be simply sum equals to sum plus I, and at the end of the print statement or the for loop, I'm going to say sum of the first n natural numbers is, and I'm going to give a comma and I'm going to write this sum variable here. Right. Now once that is done, it is waiting for our input. So let's give it 10. So this is what it returns. Sum of the first n natural numbers is 55. So we know from our mathematical background that sum of for the first n natural number, so the formula is n equals to n plus 1 divided by 2. You must have studied in this in the mathematics classes on algebraic progressions and geometric progressions or sequence and series. That's what it is called here. 10 and 10 plus 1 becomes 11 divided by 2. This becomes 5 and the sum is 55. So this is just for our cross checking that the sum that was computed by our program was indeed correct, and it was. So let's try it with a few more examples. Let's say 15 and equals to 15, that it says that sum of the first 10 natural numbers is 120. That is, sum of the first 15 natural numbers is 120. You could have also written it like this. Let's say you close this, write n over here, and write another string that starts here, and make sure to give these comma separated. Right. So let's give 15 again, and this is what it says. Sum of the first 15 natural numbers is 120. Right. And the same with any other input. Let's say 6. Sum of the first 6 natural numbers is 21. Let's say sum of the first 30 natural numbers are going to be 465. Right. So I hope this is clear. Just quickly go over this entire program, since we're still at the very beginning of our Python course, and it just helps us to visualize how the program executes when we're trying to try run it. Basically, so this is what a dry run means. We are trying to manually see what happens at each stage of the program. So let's say first n equals to 10. We're going to take the input n equals to 10 here. So there will be a variable that will be created in memory, which is going to hold the value of 10. And then there will be another memory location that will be created, which holds the value of sum equals to 0. Once the Python program reaches at this point, it sees that okay, there is a declaration, there's a definition of the variable, and there's also assignment to the same variable. So this is what it is going to do. Sum equals to 0. It's going to initialize some variable with 0. Then it is going to see a for loop which starts from 1 and it goes to it goes up to 10, including 10, and since n is 10, n plus 1 is 11, and that is why we have excluded 11. So this is how it works. So in the first iteration, there will be I variable also will be created. So this I variable will be created within loop scope. Now remember, this is the program's, this entire thing is the program scope or the global scope of the program, but this is the loop scope. Loop scope. So anything inside the loop scope, if you are defining anything inside the loop scope, it is only usable inside the loop scope. You can't use, for example, this I variable defined in the loop scope inside the program scope or the global scope. So this is what it is: global scope of the program, and this is the loop scope. So you can use anything from the global scope inside the loop scope because that is visible to the loop scope as well, but you can't use anything that is defined within the loop scope inside the global scope because it is not visible to the global scope, because these scopes are deleted or they are removed once it goes out of this limits of that scope. For example, once we exit out of this loop, I variable is going to be destroyed in the memory, which is why you won't be able to use it later in the program, right? So that's a little bit important information about the scoping rules in Python or any programming language for that matter. It's not specific to Python, but yeah, it's also followed in Python with the same intent, right? So once you get inside this loop, you have a variable I which is initialized to 1 in this case. I mean, even if you initialized it to 0, it won't matter because 0 plus 1 at the end of the day it's going to be 1. So it doesn't matter if you start with 0 or 1 for this case, but it might matter for some other case, and we'll see during our following lectures how it matters when you started with 0 or 1. But in this case we're starting with 1, so let's stick with it. What is going to happen is we see the sum variable that is defined. We are going to read what is the value of the sum variable, that is 0, and the I value is 1. We are going to do this addition 0 plus 1, and we are going to assign it back to the sum variable. So sum variable will be updated with the value 1. You go back, you do the increment, you come back into the loop. Now I is 2, but the sum is 1 and I is 2. You do the addition 1 plus 2, 3, and you store it back into the sum. So sum will become 3 this time. Again you are going to come back. You are going to do a check first. If 2 is less than 11 or 2 is less than or equals to 10, it is, which is why you are allowed to come back. So I will be 3 this time and sum will be 3. It's going to be 6. You are going to store 6 into the sum variable, and this again you are going to go back and you are going to increment I, that will be 4. You are going to check if 4 is less than 11. It is. You are going to come back, substitute 4, again read from the memory location of sum, that is 6. 6 plus 4 becomes 10. You are going to store 10 back to the sum. We are going to go back to the for loop body, that is the header of the for loop. You can call this whole thing as the header of the for loop. Right. It's going to go back to that header and it's going to increment the I variable. It's going to become 5. It's going to come back after the check, of course, that it is less than 11. Then you are going to add these sum and I, that is sum will be 10 at that point, and this I variable will be 5. Right. So you do the addition, it goes back into the sum. This becomes 15. You go back again, this becomes 6. You do the addition, 15 plus 6. What does this become? This is like 21, right? So then this will be updated with 21. This becomes 7. You are going to come back after the check, of course, that is 7 is less than 11. 21 plus 7, it will become 28. You are going to go back, update the sum memory location with the value 28. You are going to come back, with I equals to 8. Since I is less than 11, that is 8 is less than 11, we are going to come back inside the body again of the for loop. So this is the body of the for loop, by the way. And we are going to do the addition again. 28 plus whatever is the I, that is 8. So this becomes, what does this become? 36. This becomes 36, and we are going to update into some variable like 36. We are going to go back into the loop header, and this time it's going to increment it from 8 to 9. It's going to do the check, it is less than 11, right? So I will be 9, it is going to come back into the for loop body. It's going to pull whatever is the value into 36, sum, that is 36. They are going to do the addition, it is going to be 45, and you're going to store 45 into the sum. Going to store 45 into the sum, right? And then what it is going to do is it's going to go back to the loop header. It's going to increment it. If I becomes 10, it is going to do the check. If 10 is less than 11, that is true. If that is true, then it is going to come inside the loop body again. It is going to pull whatever is the value of, that is written in 45. That's 40 in the sum. That is 45. Going to substitute 10. This whole thing turns out to be 55, and it is going to assign it to sum. So sum value will be updated with value 55, and all of this will be erased. It is going to go back to the loop header, and it is going to increment from 10 to 11. At this point, it checks that 11 is less than 11, so that turns out to be false. So what it does is it checks if 11 is less than 11. This turns out to be false. When this turns out to be false, what happens is it will exit the loop. That is, it will get out of the loop, or it will terminate the loop execution, and it will come out into the global scope of the program again. And once it does that, it is going to also destroy the psi variable, because it is out of the scope of that for loop. And since it was defined in that scope, it is also the responsibility of that for loop to destroy the variable I, and which is why it destroys the memory location of I. And finally, this is what we are left with. N is 10 and sum value is 55. So this is what it is. So this is what the print statement is doing. It's going to print the first string. This is the first string. It's going to print whatever is the value of n here. It's going to pull that value. It's going to print 10. Then it is going to print this entire string again. Then it is going to read whatever is the value of the sum variable, and it is going to print 55. So that is how this entire program execution happens, right? So yeah, so that was pretty much about the basic example, of for loop. So we can do more things inside of this for loop body. It's not necessarily that there can be only one statement. There can be more than one statement as well, right? So we can also use if and else statements. For example, if okay, so now I only want to add. So in the range, whatever is the n natural numbers, let's say I modify my problem statement and I only want to add the odd numbers in this to this sum. So what I'm going to do is I'm going to just give there a check. I'm going to say if the number is odd, so this is how we check for odd numbers. That is, the current number is odd, that is I, and for checking odd we just do a modulo, a remainder operation with 2 and check if that value turns out to be 1. If the remainder is 1, so I'll say that if I modulo 2 is 1, that is if the remainder is 1 with division 2, then what I'm going to do is only then I'm going to do the addition, this addition. Some of the first n natural odd numbers is, so I'm going to give let's say 10 here. So what this is going to do is it's going to add, so I'm just going to write a comment on here. It's going to add 1 plus 3 plus 5 plus 7 plus 9. So what does the sum turn out to be? This is 4, 9 and 9, 18, 18 plus 7 will be 25. So we expect the answer to be 25. And that's what it is. It says that the sum of the first n natural odd numbers is 25. sum of the first 10 natural odd numbers is 25. We've seen how that works. Just to make sure that we get this entirely, I'll just quickly go over how this is also executed. So what happens is we give it the input 10. So n is 10, sum is 0. Then what this does is this is going to elaborate from 1 to 3, 4, all the way up to 10. But here what is going to happen is when it is going to check if 1 is odd or not. It is odd. In that case, it's going to execute this. When this I turns out to be even, something like 2, then the statement will not be executed. It will be skipped. Then it will be checked again for 3. If it is true for 3, then you're going to execute the statement. Then comes out to be 4. When you see 4 over here, which is not odd, so we'll skip it, and so on. It simply adds 1 and 3 and 5 and 7 and 9. So these are the numbers that it is going to add. So I guess this has been helpful. So I hope you've understood it. If you have any doubts, please let me know. Thanks.